Hi, in this presentation I'll show you a complex circuit having resistors in series and in parallel. As you can see here, their current is flowing around the circuit from the positive terminal to the negative terminal. One of the first jobs in handling such a circuit is to find the equivalent resistance. In this particular example, you can see that the parallel resistances are all the same. They're all of 10 ohms each, and the series resistances are 1 ohms each. So all you have to do is to bunch the parallel guys together and the series guys together. That will simplify the circuit a lot. For the parallel bunch, the equivalent resistance is 1 by R is equal to 1 by 10 plus 1 by 10 plus 1 by 10. Do it 5 times and you get 5 by 10, that's 0.5 ohms. The whole thing simplifies to 0.5 ohms. For the series bunch, the equivalent resistance is 1 plus 1 plus 1, that is 3 ohms. So overall, the equivalent resistance of the whole circuit would be the resistance of the first bunch plus the resistance of the second bunch, because both bunches again are in series. So that would be 0.5 plus 3 is equal to 3.5 ohms. Having said that, you now have a circuit with a known battery source of 12 volts. You have found the resistance of the circuit, so it should be possible to find the current flowing through this circuit. So all you have to do is to think of Ohm's law and draw in your mind a simple circuit having just one resistor of 3.5 ohms. When you do that, I is equal to V by R, this is 12 divided by one big resistor of 3.5, that's 3.43 amps. This current is constant. It will flow all around the circuit. However, we know that inside that parallel bunch that you see there, the current will get divided. There are some yellow arrows there just to show that the current will get divided at that junction between the 5 resistors in parallel. Since the resistors are all equal and all of them are 10 ohms each, the current will get divided equally among those resistors. So the 3.43 amps divided by 5 and you'll get 0.686 amps flowing through each one. Please note that in this particular example, since it's a complex circuit, the 12 volts from the battery is not fully applied across the parallel resistance. If there was no other resistance in series and all that, then the entire 12 volts would have got applied between the parallel resistors, but in this case it's not so. So be careful about that and do not use that equation with 12 volts on the parallel resistor grouping. Having said that, you have now found the current, and it's important to remember that this current is flowing through the parallel resistors. The 3.43 again comes back into the wire and flows through the resistances in series. So each one of those small resistances in series will see a current of 3.43 amps. The next thing that can be done here is to find the voltage drop. This may sound a bit intimidating, but it's not. So do the favorite thing, divide that circuit into bunches. So you have these two favorite bunches, and we know that the 12 volts supplied by the battery will get apportioned between the resistors in the circuit. So this is like two resistances in series if you consider the bunches. In the first orange looking bunch, the application of Ohm's law will tell you that V is equal to I into R. The current is a constant 3.43 flowing into the bunch, we're considering the block, and the resistance of that block is 0.5. So just multiply 3.43 into 0.5 and you get 1.715 volts. That's the drop across that orange grouping. To find the drop across the series grouping, do the same thing. So the current of 3.43 amps is flowing through this pink looking bunch, which is a total of 3 ohms. So 3.43 into 3 is 10.29 volts as a group. This is not the voltage drop across each one of those resistors. This is the drop through all of them taken as a group. Just wanted to make that very clear. You can also, of course, find the voltage drop across each resistor by simply multiplying that current by 1 ohm. So you will get 3.43 volts, 3.43 volts, 3.43 volts 3 times. Of course, if you add all of that, you should get 10.29 volts. All the voltages, the voltage drops have to add up and should add up to 12 volts, which will kind of tell you that there is no mistake in the calculation. So I hope that a complex circuit is now looking simpler to you, and please do look at some of the other solved problems that follow in this course, and I really hope that you'll be able to handle any kind of complex circuit with resistors. Thank you and have a great day. Bye-bye.